Now, I'm going to look at it mechanical, So this is what is happening in this winding here, right? Well, let's start from here. This one was here. This is a mechanical. Forget all the electrical things. This one is 0, right? It's going to go here. How much did I move?
90 degrees.
90 degrees. 180. 270, 360. Basically, my mechanical is the same. In this case, my electrical and mechanical, they are the same, right? Now let's talk about this 4-pole machine. Let's talk about 4-pole machine. The things I'm explaining here, they are the basic of the machine, but they are very important to understand them. Later on, we are going to get to the equation. It's going to be mostly like a math. You calculate current, voltage, I don't know, torque, those kind. But these are the physics of the machine. You understand how a machine works. This is very important. Now we are going to go to a 4-pole machine. Now, I don't care how we build this machine. Let's say it's a permanent magnet. These are all permanent magnets, right? And I have my rotor here again. And let's talk about this conductor. We are not going to have one, because we cannot have an odd number of conductors, right? But let's say we have only one. I'm going to look at only this one. So we're going to start from 0. Let's put it here. Oh no, let's put that one. Let's put it here. And this one is moving like this, right? Let me plot the E again here. So here, if you look at the flux, it's going to be like this. Phi is going to come from here. I wish I had a colored chart. It's going to come from N to S. It's going to come from N to S. It's going to go from N through the root. See here, this air gap is, they call this one air gap. It's extremely exaggerated. This air gap here about 1 millimeter or 2 millimeters, something like that. Then you look at the cross section of motor, barely you can see the air gap. You cannot see by eye. So again here, going from N to S. Right? So this is the direction of my flux. You can see here. Now, let's start with this one. Let's say this is at 0 angle. I should say, but let's say this is 0. Okay, this is 0 angle, right? When I am here, and this one is moving this way, so basically speed is like this, right? Because this one is rotating, this V is like this, right? So here, this is a V, and this is a N. This is a B, sorry. This is a B, right? Here I'm going to have 270 degree, right? 270 degree here, right? Let me start from here. Let's start from here. I want to this one. I don't want to start from the 270. I want to start from at least 90 degrees. So if you have a conductor here, V is like this, right? And B is like this, right? It's a B and B, right? 90 degrees, right? So here I'm going to have maximum voltage, right? Because this is the angle is 90 degree, right? So I'm going to have some voltage. This is a 45 degree, Keep in mind, this is a 45 degree. I'm going to jump to 90 degree. So basically, 90 degree is the max, right? I don't know what's happening here, but let's pass through. Come here again. If your conductor again is here, right? What's happening here? V is like this, and B is like this, right? So the degree is 270 degree now, right? So basically, here was 90 degree, here is 270, right? Right? So 270 means negative, I'm somewhere here, right? 90 degree, 270, right? So what does it mean? You know, I cannot go from maximum to minimum. I have to cross the zero, right? So ideally it's going to be where? Right in the middle, right? So basically it's going to be like, this is the how much? And this is the electrical axis. This is a 45, right? This one we call it 0 here, for example, 0 degree, right? And here is how much? 90. Now, we came here, right? I'm going to come to this point again, right? Here, how much is the voltage again? 0. So the next one, I'm going to come here, right? How much is it? Max. So from here again it's going to repeat, right? It's going to repeat here. So this one was how much? 135. This is 180. And this is the table. This is another 45 is going to be how much? 45. It's going to be 225. Another 40 is going to be 270. That is 315 and 366. Right? I agree on this one? Yeah. Now, this one was electrical. You know, I look at the voltage induced in my conductor, right? But now let's look at my conductor. Mechanical. I'm going to go mechanical. Just I'm going to put the axis here to take it. Let's say again here is 0. Let's say again it's 0, 0 take mechanical, right? I went from here to here. Mechanical again. How much did I rotate? 90 degrees. So basically, this point is equivalent to where? 90 degrees. I'm going from here.
Because the x-axis label up there is x-axis label up there is the beginning of the line.
No, let me say here. I went from.
We start from 90 degrees. Right?
We're going 0 to the top.
No, we are missing something. You know, maybe down I draw it. I started from here, I am maximum. Coming here, I become 0. Coming here, I become minimum, right? And 0, maximum, 0. That one's two sides. Oh, no, you know what happened? Then what I put here is theta m. This is the theta m. Sorry.
You're using the left hand.
No. Forget the left hand or right hand. See, you know, look at here. Those ones I plotted over there. The white one I plotted over there. Here is a 0 mechanical degree, right? This is a 45 mechanical degree, right? And here is a 90 degree mechanical degree, right? See, I'm rotating this one mechanical, but I made a mistake. It's not electrical, right? But see, this is a 360 mechanical, right? It's a 360 mechanical, right? So see, I moved from here, I went one full turn, right? 360 mechanical. Well, look at my electrical waveform. How many cycles is the electrical waveform?
2.
How many cycles is the electrical waveform? 2, right? If you look at theta E here, let me this one theta E. See, from here to here is the 1 cycle, right? So 1 cycle means how much? 1 cycle means how much? 360, right? 360 degrees. Another cycle from here to here. How much is this one? 720, right? So what I put here, I made a mistake. It's a mechanical degree, I put it here. I said 0, 45, 90 degree, 135, 180, and went that way, right? Well, look at the waveform. We have 2 cycles. 2 cycles means 2 times 360 degree, right? So what's the relation between theta E and theta I?
Theta E is double. 2 theta E.
Right? What was here? Now I'm going to put something here. P is the number of poles. How many poles do I have here? 2. Come here. See. I have 2. How many poles I have here? 4. Now, tell me I have 6 poles. What's going to happen? If I have P6, what is the relation between theta E and theta? Right? So what's the equation? Theta E is equal to P over 2 times theta S, right? So this is the relation between the electrical angle So how about relation between the electrical frequency and mechanical frequency? Can you tell me? You know, omega, angular velocity is defined d theta over dt, right? Angular velocity is defined as d theta over dt, right? So from this one, we can say omega E is 2 omega f, right? What is the omega? Is a 2 pi f, right? So basically I can say Fe is equal to f. So electrical frequency is 2 times, for this circuit, is 2 times of mechanical frequency. In general, Fe is equal to, well, 2 should be P, sorry, P over 2. This one should be P over. And this one should be P over. Correct? So now we know what's the relation between the electrical frequency and mechanical frequency. And I want to know what was the next one. We're going to talk about after this topic. So, yeah. So one more thing I want to say as a definition. Somebody had a question here?
So what does electrical look like? Is it like, does it just look the same as over there?
Electrical?
Yeah.
This is electrical. But this angle here, this angle I put here is a mechanical angle I put here. If we have one rotation, mechanical rotation, the voltage is going to go like this. If we are going to plug this one again here, just plug this one again here, it's going to go like this. So this is a 0, this is 360, this is a 90, 180, 270, and 360, and 4. This voltage I put here is electrical voltage.
Why does it start at 90 over here?
Because,
max.
because we started under this pole, right under this pole, you know. If I would have started in the middle, it's going to start from 0. I started from here, it will start from here. When I did that one, we started from here. See, between the poles, right? That was 0. And here I started right under the pole. The next thing they call it pole pitch. Just I want to know, pole pitch is defined one pole pitch electrical. One pole pitch is defined as 180 degree electrical. 100 degree electrical. So now, can you tell me how much is the pole pitch here?
2.
Can you tell me what's the pole pitch here?
2.
So pole pitch is degree.
Oh.
2 degree cannot be. So you start. We want to say it another way. You should start from N. Go to get to the next S. They call this one pole pitch. How much is the one pole pitch here? 180 degree. Electrical, everybody is 180 degree electrical, but 180 degree mechanical as well, right? How much is the pole pitch here?
45.
I have to go, no. It's still in the 180, see, all the time is 180 electrical. You go from N to S, right? 180 electrical. I'm going from here to here. How far did I go electrical? I went from N to S. N to S is 180, right? But how much is mechanical?
90.
If you had a 6-pole machine, from one pole pitch electrical 180 degree, there is 60 degree mechanical, right? So again, the same equation with the P, you can say the electrical pole pitch is equal to P over 2 mechanical pole pitch. So this is the definition of pole pitch, and I wish I had a little bit more time, but let's stop.